Hello everybody, this is paper 1 from May 2023. This is time zone 2. Alright, question 9. 6 marks. The lengths of the seeds from a particular mango tree are approximated by a normal distribution. So already we know we're in the realm of normal distribution. Norm CDF or inverse normal. And the lengths of the seeds are approximated with a mean of 4 and a standard deviation of 0.25 centimeters. A seed from this mango tree is chosen at random. Calculate the probability that the length of the seed is less than 3.7 centimeters. So remember, when we're talking about a normal distribution, we have this bell curve, and it's symmetrical and it's centered about the mean, which in this case is 4 centimeters. And we have this standard deviation, which is a measure of spread, and they're telling us that the standard deviation is 0.25. And not super necessary in this case, but remember, for our standard deviation, we have roughly 68% within one standard deviation, and then we have 95% within two standard deviations. Small standard deviation tells us that we're tightly clustered about the mean. Larger standard deviation means we have something that is more spread out, data values that are further away from the mean, more like distributed further away from the mean. It would be flatter, our standard normal curve. Okay, so part A asks us to calculate the probability that the length of the seed is less than 3.7 centimeters. 2-mark question. Remember, for this, if you're not sure how to work this out, process marks at very least are a sketch. So throughout, I'm going to draw a sketch here. So calculate the probability that the length of the seed is less than 3.7 centimeters. So here's our normal curve, here's our mean of 4, and we want to find the probability that we have a length less than 3.7. So if the area under the curve represents all of these seeds, we're looking for the percentage that is to the left of this 3.7. So less than 3.7. That's what this is. It's less than 3.7. Okay, so let's go to the calculator. Let's go menu, probability. In this case, we're in distributions, and we're going to use norm CDF. And so, our lower bound, we can keep this as some massive negative value. The idea is we just want to capture all of the seeds to the left, or that are less than this value of 3.7 centimeters. Our upper bound is 3.7, so everything below 3.7, from some massively negative value to 3.7. Our mean in this case is 4, and this is our standard deviation. Our standard deviation is 0.25. Just one last thing. If we're in normal distribution and they say less than, we don't have to worry about less than or less than and equal to for normal distribution. We just put a value, 3.7, this is our upper bound. Okay. Let's go ahead, and we have roughly 11.5% of our seeds are less than 3.7 centimeters. So let's go ahead. This is already method mark, so it's okay. But I'm going to go ahead and write norm CDF and then put those values in. So I'm just going to put -999. Essentially, we can put 0, a seed of 0 length or something like that, or slightly greater than 0. 3.7, this is 4, and 0.25, mean, standard deviation, lower bound, upper bound. And we said that this was equal to 0.115. You can write this as a percentage if you want. Okay. Part B, it says, it is known that 30% of the seeds have a length greater than k centimeters. Find the value of k. So in this case, we're given the area under the curve, and we want to find the cutoff point. So let's go ahead and draw another sketch to see what this actually is. So we've got a normal curve once again. I'll rewrite that actually, make it a little better. Okay. Here we go. A mean of 4, and it is known that 30% of the seeds have a length greater than k. So we only want an area of 30% and we want it to be greater than some cutoff point. So in this case, let's use red. We have some cutoff point k, some value k, and we want only 30% of the seeds to be greater than this value of k. So, okay. Alright, so in the first question we had a cutoff point and we wanted to find the area. That was our norm CDF. Here we have the area, but we need to find the cutoff point. So if this is normal, we're going to use inverse normal here. So let's go to the calculator screen and work this out. Menu, probability, distributions, and in this case we're going to go inverse normal. So the area under the curve, actually going to go back to the document one sec and just explain something. So our calculator sweeps out from left to right. So when you give it a cutoff point and you're asked to, we're telling the calculator rather what area you want to sweep it through. If we would just put 30, the calculator sweeps from left to right and it would actually work out this value right here. But we want the calculator to sweep through 70% so that only this 30% is remaining. So to go back to the document, sorry, the calculator rather, the area is going to be 0.70. So we're interested in the cutoff point for which 30% of the seeds are greater than this value. If the calculator sweeps from left to right, we want it to sweep through 70% of the values to reach this cutoff point. Mean once again is 4, standard deviation 0.25. Okay. And here we go, 4.1311. This is that cutoff point, the length of the seed, 4.13 centimeters, and 30% of the seeds are greater than this value. So let's go ahead and type this in. Alright, so k is equal to 4.13, and that's reassuring because it's to the right of the mean. And that would give us this 30%. This is already processed, but I'll write this out as well. Inverse normal, and then we put the area that we want to sweep through, in this case the mean and the standard deviation, and that gave us a value of 4.13. Okay. This is a nice question right here, part C. For a seed of length d centimeters chosen at random, the probability that we're within this certain range, centered about d, is equal to 0.6. So where we're some distance m, 4 minus m, where d is greater than 4 minus m and d is less than 4 plus m, the probability of being within that range is equal to 0.6. So I'm actually going to draw a sketch, and I think that'll help kind of determine what's going on here. So let me just move this over a little. That's fine. Okay. So kind of, I think it's a good question, but what is actually going on? So these values of 4 should give us some indication. D is some central point, and 4 minus m, and then 4 plus m. What are we actually talking about? So let's draw a bell curve here. We know our mean is equal to 4. And if we're 4 minus some distance of m, so what might that look like? So let's just say this is m right here. This point right here would be 4 minus m. So d is greater than 4 minus m. So some point d is greater than 4 minus m. And if this as well is, let's say, a distance of m, this line right here would be equal to 4.5, so what am I saying, 4.5, 4 plus m. And this last point of this 0.6, so is saying that the probability that we're within the range where d is greater than 4 minus m and d is less than 4 plus m is equal to 0.6. Or, what we've seen before, this is the area or percentage under the curve. So what that means is that, and I'll keep this in blue I suppose, or red and green I guess, we're dealing with 60% or 0.6 of this standard normal curve. 60% of the values are within this range where m is some distance less than 4 and some distance above 4. Let me see if I can summarize that once again, just from the top. Standard normal curve gives us all of our values, all of the seeds are within this range, or under this curve, centered about the value of 4. If we're talking about 4 minus m and 4 plus m, these are the cutoff points where we're going to have 60% or 0.6 of all of our seeds between these two cutoff points of this range right here. So the probability that we're within this range is equal to 0.6. Alright, so that's quite a bit, and to be honest, this sketch right here would be enough for process marks, 1 process mark. How do we find this out? So we're looking for a cutoff point, we're looking for this cutoff point here, and so we can ask the calculator to sweep through a given range. And if this right here is 60%, then we know that this is a symmetrical distribution centered about the mean, and that would mean that this, oops, let me get another point, this itself would be 20%, this of course is 60%, and this would be 20% right here. And so, what are we asking the calculator to do? We're asking it to sweep through a range of 20% right here. Okay, so let's go back to the calculator screen and work this out. Menu, probability, distributions, inverse normal. The area that we want to sweep through is 0.2, mean is 4, standard deviation 0.25. Okay, and it's 3.78959. So let's go back to the document here. We know this is 3.78959. And so what did we say? If this is 4 minus m is equal to 3.78959. Essentially we're asking what is the difference between this cutoff point and this. That's what m is. M is the difference between the center value and this cutoff point. So 4 minus m is equal to 3.78959, or the distance between 3.78959 and 4. That's alternatively what we're doing here. 959, 4 minus that is just going to give us a value of 0.210. Alright, that's the value of n. 0.210.